A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm the same. Thank you. We shall be starting in a couple of moments. Okay. So, hello, a very warm good morning to all of you, and welcome to Baiju's Exam Prep IAS. Welcome to another session of Geography, where today we shall be moving ahead with the portion of Indian physiography in the part of Indian geography. So, yesterday we had done the part of the portion that we had covered yesterday in terms of Indian geography was basically the basics of location and the locational aspects, as well as India's physiography in brief. And there we had talked about the northern mountains and the features of the northern mountains as is experienced from west to east, and also the few of the landforms that are created in these mountainous areas, including dunes, duars, then also including karevas, bugyals, etc. That is something that we looked at. Before that, yesterday we had completed the portion of oceanography, where we had taken a look at the detailed portion of what do we mean from thermohaline circulation to the aspect of ocean currents to what is global conveyor belt, what do we understand by Sargasso Sea, what are coral reefs, coral bleaching, and different types of coral reefs. All those factors we had looked at yesterday. So today, we shall be moving ahead with the portion of Indian physiography. We shall be trying to understand the formation of the remaining five physiographical divisions that are there. And we are going to try to understand their associated formation and physical features. Then, after that, we shall be moving ahead with the aspect of drainage and river systems in India. There, we are going to develop an approach how to address the portions of river systems in types of the questions that are asked from there. And then again, eventually, that will lead us to forest and soil. No, Haridwar is not a duar. Duar is Duar. Haridwar in that Dwar. And Haridwar basically it literally means a kind of a gate. So, gate of the gods. So, that is where it is not a duar. Please understand, duars are present only in eastern Himalayas. And Haridwar is present where? In the region of Uttarakhand. So you cannot have presence of duars in the region of western Himalayas, that is from Uttarakhand, Himachal, and Jammu Kashmir. You cannot have the presence of duars. Okay. So now we start with the northern plains and its formation. How is it that these northern plains came into existence? So basically, here also for a very long period of time, there have been various different theories which have been floated around, various different theories which have been in existence. That how these very fertile plains of the north, extending all the way from the region of Punjab and Haryana, all the way till the region of Assam, how did these plains come into existence? After all, these are one of the most fertile plains that you will come across. And in many of these areas, it has been found out that the depth that these plains have, the depth of the sediments that are present in these plains, that depth is quite significantly large in the sense that in many of the areas, the depth of the plains is close to around 2 kilometers and in certain areas even more. And now we know that the level of the plain is almost close to sea level. So how is it possible that we have sedimentary deposits basically which is 2 kilometers thick, and then on top of that now it has reached the sea level? So that means there must be something amiss, or there must be something about the formation of it. So various different theories have been floated around by Indian geologists, geographers, and also geographers and geologists across the world. So here now let us understand that what is this formation about, and let us understand the concept of formation as associated. So here one of the leading geographers or geologists who basically gave the solution or gave the theory for the formation of northern plains, that is Edward Seuss. Edward Seuss. Now, Edward Seuss, you would have heard about his name in the earlier portion of geomorphology. While we were discussing geomorphology, there also we come across this name. So you would have heard about his name in the portion of continental drift theory when we talked about the assumptions which were made by Alfred Wagner. So Wagner had borrowed the concept of interior of Earth from Edward Seuss. That is where we had used this name earlier. So when it comes to the northern plains, Edward Seuss provided a theory, a kind of a concept, and that is the theory or the concept of a four deep. The concept of a four deep. Now, what is a four deep? So break this down. Any part which is not understood, break it down. Four deep. So it is made up of two small words, fore and deep. Fore means something which is in front, right? Aforementioned. That is how you use the term fore in English, aforementioned and so on. So fore basically means something in front, and deep means a kind of a depression, a kind of a syncline. So here, what do we gain from the aspect of fore deep here? So when you talk about four deep, basically here Edward Seuss had postulated something very interesting. He said that look, if you have, let's say, if you have any kind of folding which happens, now it is not only going to be an upfold. Beyond that, there is going to be a downfold as well. So a land merely cannot get folded up like this. The land, in order to get equilibrium, will generally exhibit a kind of a fold like this. So the concept of 4D talks about the formation, the existence of a kind of a depression, a very elongated and a large depression, which was formed in front of the Himalayas. As the Indian plate was colliding with the Eurasian plate, immediate boundary region experienced a kind of an upfold. Now, in order to compensate for that upfold, the ground underwent a kind of a depressed formation immediately beyond the region of Himalayas, immediately to the south of Himalayas. Until which region was the ground folded? So till the hard rocks of Peninsula Plateau. That is where the ground was folded significantly. That was the concept, the postulation. So he basically said that look, if you consider the Indian plate will exhibit something like this, where let's say these were the Himalayas, right? Let's suppose this is the region of Peninsula Plateau. Okay. So in front of the Peninsula Plateau, you have a depression, or just ahead of the Peninsula Plateau, you had a depression created to the south of Himalayas. And this was a depression which was created as you had the upfold of the Himalayas happening. That is where the depression was created. So this depression or it can also be referred to as a geosyncline, because synclines and anticlines we have studied. So this syncline was created as a result of upfolding observed in the north in form of Himalayas. So because there was an upfolding, a compensatory synclinal formation also took place in order to gain a kind of a stability. Now, only when we consider the Indian plate, you have to understand that the original Indian plate, when it was not, or when it did not collide with the region of the Himalayas or the region of the Eurasian plate, so it consisted of a significant proportion of the peninsular plateau all around. But there was some amount of landmass, a kind of a plain deposit, which was present earlier as well. So after this collision, it is these areas which got upfolded, and it is in this area only where a downfold was also created. Later on, you had massive and mighty rivers originating from the Himalayas, which would drain this area. Very massive rivers, which are also referred to as the Indo-Brahm river systems. And you had the rivers in the form of Indus, Ganga, Brahmaputra, which would end up draining through this area of the 4D. And as these rivers would drain from this area, it was a kind of a depression. So that is where these rivers would start depositing the sediments. And these sediments would be deposited. All these areas, you would observe the sedimentary deposits. And these sedimentary deposits now have reached a level of the sea level in general. So that tells you basically about the formation, or why is it that northern plains is so very deep in terms of sedimentary deposits. Sedimentary deposits in many of the areas can be gauged to be around 1 to 2 kilometers easily. So this depth of sedimentary deposit, this is the northern plains. The deposits of sediments are carried, or rather were carried, by the Indo-Brahm rivers, as they are referred to, or by the major Himalayan rivers, which are those major Himalayan rivers: Indus river system, Ganga river system, and Brahmaputra. So that is basically the formation process, how this was formed. It could not be formed, it could not have a deformation from the region of the peninsular plateau onwards, because it is from this region onwards that you have the presence of hard rocks, the igneous and the metamorphic rocks which constitute the peninsular plateau. That is something which is to be found here. That is why it was not formed in this region. Okay. Now, after this, if we take a look at few of the features of the northern plain, so basically they are formed by the alluvial deposits brought by these major rivers. They extend significantly west to east with a width of around 150 to 300 kilometers. Now here, it is widest in the west and narrows down to the east. So if we take a look at the map of the country, then basically from the region of Punjab, Haryana, and so on, that is where you will find, and then you enter into the region of UP, that is where you will find that it is significantly wide. The northern plains, that is the north to south extent, is significantly wider. But as and when you move towards the eastern part of Uttar Pradesh, then you move on into the region of Bihar. There you will find that it becomes the narrowest in the portion of eastern Bihar. That is because the peninsular plateau has got an extent up till there. So these northern plains, they just like the case of Himalayas that we talked about, here also you have a basic classification or differentiation in the form of you have the upper Ganga plains, the middle Ganga plains, the lower Ganga plains. Upper Ganga plains in the western region of Uttar Pradesh, middle Ganga plains in the region of central Uttar Pradesh, eastern Uttar Pradesh, and portions of Bihar. And then you have eastern or lower Ganga plain, that is the region of West Bengal. So the lower Ganga plain, for example, that is also referred to as Rad plains, Rarh, Rad plains. Then you have, for example, the Punjab and Haryana region, that is the Indo-Gangetic. So it consists of both the Indus River Basin as well as the Ganga River Basin. So that is the extent of the northern plains. Now, when we talk about these northern plains, you have to understand that the materials which are present, the alluvium which forms these northern plains, that has been brought down by the rivers and is replenished in many parts almost annually. That is why this is very, very fertile. But here you have to understand that when we talk about these northern plains, let's suppose from here to here, the entire stretch from north to south, it is not going to have a homogeneous formation or a homogeneous structure of the grains or the rocks. The structure is going to be differentiated. The structure is going to be very, very different. So the northern plains overall, if you take a look at the structural anatomy of it, so it is divided into Bhabar, Tarai, Bhangar, and Khadar. Right? What are these? Where are these created? Let us try to understand that. So you will observe that immediately to the south of Himalayas, you will find a very different structure of the materials which are present on the ground surface. These are also brought by deposits. Then after that in Tarai, you will find a different kind of substrate and so on. All these are nothing but part of northern plains itself. So northern plains in structural orientation can also be subdivided into various parts. Let us take a look at them. So we start first of all with the basic understanding about how these depositions end up creating different kind of structural anomalies. So let's suppose you have the presence of Himalayas in this region. Let's suppose. Now, the rivers would be originating from the region of the Himalayas. Okay. Now, these rivers would be originating from the region of the Himalayas. Now, as the rivers are coming down the slope, they will bring down, they will have a very high speed, very swift movement. So they will have the ability to carry very large rocks and boulders, which otherwise the rivers could not have carried. But because they are moving down the slope, many large boulders and rocks, they come on sliding along with the river. But as soon as the river hits the plain area, that is where the issue starts, in the sense that as soon as the river hits the plain region, here, all those boulders that it was carrying, it will start getting deposited immediately. Why? Because now the speed has reduced. So the carrying capacity will drop immensely, almost exponentially. So all those large rocks and boulders that it was carrying, all of them will get deposited here. All of them will get deposited here. Now, these rocks and boulders that you find, in a way, Let's say if you are asked to look at it from above. Now, these rocks and boulders, they will be able to block the entire region where the river is moving. In many of the cases, because they are dumped onto the riverbed and they are piled upon each other, in many of the cases, even the river is not visible. If ever you get an opportunity, let's say in the most accessible places where you can have a look, have a witness at these bhabar or these kind of formations, you can basically observe, if ever you have walked or moved in a non-national highway portion between Rishikesh and Haridwar, or even upstream of Rishikesh. There you will find across River Ganga that you have many such boulders which are deposited where the river basically it becomes very narrow because majority of it is hidden by these rocks and boulders. And here, in fact, if you go in the evening time or night time, it is much more scary because the river is not visible. Why? Because it is hidden by the rocks and the boulders. But you will hear enough gurgling noise of the river because the river is still moving in a significantly comparatively faster velocity. And the river makes you feel that it is perpetually present there. So that is why this is a tract or a region of stony boulders and stony rocks. And this is what is referred to as the Bhabar tract. The Bhabar region. Okay. This is the Bhabar region. Now, in this Bhabar region, do you think agriculture can be carried out? Obviously not. So, not at all suitable for agriculture or cultivation because this is rocky substrate. But here, individual trees you can find around here and there in isolated portions. You will still be able to find a tree here or there, but no agricultural purpose is carried out. Now, after this, after crossing this region, after crossing a stretch where these stones and boulders have been deposited, these basic rivers, they appear to almost re-emerge. And they appear to re-emerge. Why? Because now there are no boulders. Now, when they then again are apparent on the surface, at that point of time, they come to a sudden flat area. Imagine sudden flat region. So they are coming down the mountains, they have deposited the boulders, they are moving around, and now there is everything which is absolutely flat. No designated river channel. River channel, basically, when you take a look at the river in motion, you would have observed that as the river ends up moving, there's a kind of a channel, a fixed path. So here, as the river comes up beyond the Bhabar tract, it comes to an area where there is no designated river channel. So what the river does, the river bifurcates, trifurcates, and significantly divides into many small channels, starts flowing here and there. Many small channels. Wherever it finds any kind of a slope, the river will end up draining there. Now, in that condition, what will happen is when you have multiple such streams, again, if you want to witness this, go to the foothills of Himalayas in the region of either northern part of West Bengal or in the region of Uttarakhand or in the region of Himachal Pradesh. You will be able to understand this kind of a formation. You will be able to witness this kind of a formation very easily. So that is where you will find that many small streams, they are present, right? Even in the case of a mighty river like River Ganga, you will observe that River Ganga is moving in a particular area, but it has got many different substreams moving parallelly with it. So these small substreams, they make the entire area very marshy, very swampy and muddy in nature, right? Why? Because there's a kind of an over availability of water here as the river is moving across the plain, dividing across the plain. So you have a kind of an over availability of water. So that is where you will come across a very marshy area, muddied region. And it is in that marshy and muddied region where you will have lush growth of vegetation. Very dense vegetation. And dense vegetation, why? Because availability of water is there. Now, in that situation, when there is a dense vegetation, automatically the faunal species will also come there. That is why the foothills of Himalayas are particularly dominated, or at one point of time, they were particularly dominated by the tiger population, the rhino population. All of these were very dominant in that region of Himalayas. So that is basically the region which is referred to as the Tarai belt. Now, here again, eventually, as it moves ahead, that is where all these streams will come together. All these streams will come together to form that large river channel. Right. So this particular portion, where in a way river simply ends up behaving as a multiple group of rivulets or streams, this is what is referred to as the Tarai belt. If ever you have read through the Ruskin Bond stories in your childhood days, in your school days, I'm sure all of us are aware who is Ruskin Bond. So, uh, if you would have read about his stories, the fictional stories that he would write, now he would use the term Tarai quite significantly, particularly to describe the region around Uttarakhand, around the region of Dehradun, and so on. So that Tarai belt would be used very prominently in his stories. But nonetheless, in India, for example, if you take a look at Corbett, the Corbett Tiger Reserve, that is based on the Tarai Belt. That is very much present in the Tarai Belt. So Tarai Belt, very rich in biodiversity in terms of the trees and also the animals. Why? Because of swampy and marshy conditions. Now then after that, the river enters firmly into the plain area with a marked river channel. It is there that the river will flow. Now, this is what is referred to as an alluvial plain. Alluvial plain. But alluvial plains are also of two types. You have the newer alluvium and you also have the older alluvium. So, alluvial plains are also of two different types. So, here you have the newer alluvium and or newer deposits. That is what is referred to as khadar. And then you have older alluvium, which is also deposited. That is bhangar. So let us understand how this khadar and bhangar are created. What is this concept of a newer alluvium and older alluvium? Let us understand that. So here, let us think about the floodplains. The floodplains we have seen in the portion of geomorphology itself, right? The deposited area created as a result of the river action. So suppose this is the landmass. Suppose this is the landmass. Here you have the river channel. Okay. And the river is virtually moving into this area. The river is moving into this area, this region. Okay. Now, here, as the river is moving, it will end up depositing materials immediately on the banks of the river. As it is moving, immediately the deposits will be carried out on the river banks. Here. And this will be carried out on a very frequent basis. on a monthly basis, on an annual basis. This will be carried out on a very frequent basis. So this is the deposition which is carried out very frequently. So this will be your newer alluvium. Then what is the concept of the older alluvium? So sometimes, let's say somewhere maybe 100 years, 200 years in the past, let's suppose the river would have flooded to an extent. Let's suppose the river would have flooded to an extent that the entire region, let's assume, would have been flooded. The entire region would have been flooded. Now, in that case, now this is not a very common instance. This is something which happens in a long time period, once a while. So let's say there was a flood around 150, 200 years ago, and that was flooded in that entire region. The entire region was flooded overall. Now, these would carry out deposits even in the far-flung places. Even here, the deposits would be carried out if the flooding would have happened. Okay. Even here, the deposits would have happened. Now, these deposits are not getting replenished year after year, or even in a decade, it is not getting replenished, or even let's say in 100 years, these deposits are not getting replenished because it has happened a long time back. So these deposits which have been carried by the river while the river was flooded, so these deposits are what are referred to as the older deposits or the older alluvium. Okay, so older alluvium is very far away, significantly far away from the river channel. Older alluvium. Whereas when we talk about newer alluvium, that is very close to the river channel. It is significantly closer to the river channel in general. So that is the factor that you end up finding in this case. Now here, basically, if you will observe the region of the older alluvium. Now in this region of older alluvium, you will come across a scenario. Let's say these deposits have been carried out a long time back. Let's say these are the deposits carried out a long time back. In fact, when you think about the deposits, always better to think about it in terms of the particles in general. Think about the deposits in form of particles. Always it is more relevant. So let's suppose you have had a series of these deposits which have happened long time back. Now these are small grains and nodules which have been deposited over a period of time by the river action. Now you have to understand, as these deposits, they tend to pile up, they will have their own set of weight, right? They will have their own set of weight with the availability of moisture. Sometimes they will become heavier. There will be various different contaminants, etc. So this deposit will tend to become heavier and heavier on what? On the base. So the base of it will be experiencing a lot of weight of these deposits. Now, under that huge weight of the deposits, the lower portions of these deposits, the lower grains or granules of these deposits, they tend to get crushed. They get crushed, and whatever small amount of fluidy, pasty thing that is available in general, when the rivers move, they carry significant amount of calcium. So whatever amount of calcium is present within the grains, that simply spreads out. And calcium has got a binding property. So that is where, under the weight of the particles, first of all, the particles in the lower region, they get squished. The calcium comes out, and that calcium combines with various different other particles. It leads to the formation of larger nodules. And these larger nodules are calcareous concretions, which is referred to as concre. What do we mean by calcareous concretions? Basically, in the presence of calcium as a binding agent, many small particles they get together. So that is what is referred to as conker, generally found always in the case of older alluvium. Okay, is that understood, or any doubts that we have? Natural levees are associated with newer alluvium, yes, but this newer alluvium deposits, they extend further, much greater than the extent of the natural levees. These are very fertile. Here you can virtually grow any kind of crop. When we talk about the older alluvium, only a certain part of certain types of crops, such as maize, pulses, millets, these can be grown. Sometimes even certain kinds of oil seeds rather, they can also be grown. Whereas when we talk about, let's say, the newer alluvium, you can grow almost any type of crop in that region. Sai Babu, please once again explain Dhabar or Bhabar. Bhabar contact. Bhabar is basically, okay, listen to this carefully. Bhabar is basically formed immediately at the foothills of the mountains, very similar to the formation of alluvial fans that we saw about. So very similar to the formation of the alluvial fans. Now here, as the river is going to come down, that river while coming down is going to bring lot of large boulders and rocks along with the sediments. Now, these large boulders and rocks, the river is able to carry precisely because of the reason that it is coming down the slope with a high speed, with a high velocity. Now, as it is coming down the slope, it will be able to carry all of these. But as soon as it hits the plain region, the speed will be very slow. So that is when all these larger rocks will get deposited and dropped there. And if you have a riverbed, on top of that, you start depositing large rocks, eventually the rocks will pile up. And that is where it is referred to as the Bhabar. Now, beyond the Bhabar, as the river sets to re-emerge from under these rocks, basically, imagine if the river, let's suppose if there is a kind of a river channel, a fixed river channel. River knows that it has to flow through here. But instead of the river channel, let's suppose you have the flat featureless plain immediately beyond the region of the Bhabar. If you have a flat plain, it is not exactly flat, but let's suppose we consider a kind of a flat plane. Now, in that situation, the river can move from here also, from here also, from here also, anywhere. So that is where, as the river emerges beyond the Bhabar tract, it can re-emerge and it basically divides itself into multiple small channels because it is an absolutely flat plane. And when you have multiple such small channels in existence, so it will oversaturate the soil with moisture. That is the Tarai belt, immediately to the south of Bhabar. Okay? Yes, alluvial fans are found in the Bhabar region. Kankar is basically to be found in Kankar is in the colloquial Hindi language, or is also something that you use. Kankar, basically, you will observe these are calcium concretions. Basically, when you have the weight imposed by the sediments on top, the lower sediments or the lower grains, they end up squishing or getting squeezed under that huge pressure. And that is where slowly and steadily the calcium, etc., and other minerals that any grain has, that starts getting released. And that combines with the other small grains to form a larger particle, and that is a conker. Okay? Is that understood? Okay. So Bhabar is basically a narrow belt of 8 to 10 kilometers parallel to the Shivalik range. The rivers disappear in this zone and deposit heavy materials of rocks and boulders. The area is not suitable for agriculture, so it is around 8 to 10 kilometers parallel. This is not suitable for agriculture, however, isolated trees are to be found. Okay. Then, to the south of Bhabar, you have the Tarai having an approximate width of around 10 to 20 kilometers. So here, streams and rivers re-emerge without any properly demarcated channel. And that is where a marshy, swampy condition is created, luxurious growth of natural vegetation, and that is where it houses a very wide variety of wildlife. So all the national parks and the wildlife sanctuaries across the region, for example, from Corbett to Rajaji to Dundwa to even in the case of Pilibhit Tiger Reserve, to Valmiki Tiger Reserve in Bihar, to Buksa in West Bengal, to the region of Manas, Orang, Pabitara, all the way into the region of Assam. All these are significantly based in the Tarai belt. At one point of time, all of these were significantly populated with tiger and one-horned rhinos. But now the tiger population has been restricted. So all the area Katarnia Ghat and the Tarai region. So recently you had the latest elephant reserve, which has been demarcated in India. The 33rd elephant reserve is the Tarai elephant reserve, right? The Tarai protected area. So that is again where you will find rhinos, tigers, everything, because very luxurious and dense vegetation. Okay. Yes, we do have a very lush and, in fact, very lush, green, and beautiful tarai in West Bengal, even in Assam. If you get an opportunity to visit these areas, it is a sad thing that at one point of time, these tarais were so densely populated. It is a sad thing that now you don't find forests in that area. Significant amount of deforestation was carried out. And you would have read it in history, your modern history portion, why deforestation of tarai was carried out, right? Why is it that deforestation of Tarai was carried out? All those who have read the portion of modern history. Good, Pranay. Very good. So you have one factor that you have pointed out. Timber for what? Not for money lenders. Good. Beautiful. Benita and Pranay, both of you are Ajit also correct. So basically, the Tarai was deforested because of couple of reasons. First was for the railway sleepers that you have, right, in between the tracks. So that is where a lot of deforestation was carried out. And secondly, India at that point of time was requiring a lot of paper because the reading population, the population who would read, that was increasing tremendously in the late 1800s. And that is where, for paper pulp manufacturing, you had a lot of these vegetation cut off. Now, at that point of time, you would observe, you would have read it in modern history, so I will not try to interfere in that area. But that point of time is when a lot of these paper bills that started coming up in the region of West Bengal. And all that transport would happen through the streams, the rivers, moving from the region of northern part of West Bengal or Bihar into the lower or southern part of West Bengal. So that is where the deforestation happened. And when the deforestation happened, all these animal species, they lost their vital habitats. Okay. Then after that, we have the alluvial plains. So the alluvial plains, they are carried out. These are the deposits carried out in the floodplain region. So it is divided into Khadar and Bhangar. Bhangar is the older alluvium along the riverbeds forming terraces, right? So older alluvium along the riverbed that is far away from the river channel. So if let's say this is the river channel, here you will find the Bhangar. The terraces are impregnated with calcareous concretions, which are referred to as kankars. Many of these kankars you will find in this region of Bhangar, not in Khadar. Khadar is very fertile soil. So rice, jute, everything can be grown in Khadar. But in Bhangar, the coarse grains, millets, maize, pulses, these can be grown in the region of Bhangar. So here understand, just by looking at the physiographical divisions, just by understanding the physiographical properties, look at how we are able to even conclude that what kind of crop should be ideally grown there. So that is where India's physiography, if you take a look at the very basics from the point of formation, that is where it becomes very easy and it becomes very conducive as well. Okay. So this regional division or classification of the northern plains, that is done depending upon the region that you are in. For example, when you talk about the region of Punjab and Haryana, that is also very much a part of the northern plains. But there you have the presence of both Indus as well as Ganga. So that is the Indo-Gangetic plain in significant proportion, right? Upper Ganga plain, western part of Uttar Pradesh, almost to the central portion. Middle Ganga plain, central portion of Uttar Pradesh, almost up till Bihar. Lower Ganga plain, from the portion of Bihar all the way around West Bengal. Okay. Now that lower Ganga plain also referred to as Rad plains. And then eventually you have the Assam plains referred to as the Brahmaputra plain region. Okay. After this, we come to the Great Indian Desert, which is also what is referred to as the Thar Desert. The Thar Desert. Now here, Thar has been a desert, not for always. The creation of the Thar Desert is a recent phenomena in terms of geographical feature. It is expected that only around somewhere 55 to 60 million years back, that is when it started turning into a desert. Now, why did it turn into a desert? Where did the entire formation come into existence? So it all started, first of all, with the formation of the Aravallis. The Aravallis are one of the oldest fold mountains across the world. When the Aravallis were getting formed, the Indian landmass was nowhere as it looks today. They were formed on one area, on one small landmass, that is the region of Bundelkhand and the region of the Aravallis in the present day. That was supposed to be one building block of mass, which underwent collision with the oceans of those times, and you had folding. So Aravallis were significantly tall as well, so much so that it is estimated, based upon the deposits, that you had massive glaciers. What you observe in the case of Himalayas right now, that was a feature of the Aravallis at one point of time. Now, all these glaciers would feed massive rivers, and these rivers would carry out deposits across the region, which today you see as the desert area. Across this entire region, it would carry out these deposits. Now, as the Indian plate started moving northwards, as it was in the region of equator, because Indian plate has come from the southern hemisphere and has basically crossed equator to reach where it is. So it is estimated that as it was crossing the region of equator, this region received very dense rainfall, very heavy rainfall, and it would create forested landscape in this region also. But then, as and when the Indian landmass and the Indian plate, if this was the Eurasian plate, let's suppose this was the Eurasian plate, as and when the Indian landmass was closing in, narrowing in the Tethyan Sea portion, the Tethys Sea was getting narrowed in and the water was exiting from the sides. Significant portion of that water came over land. And this is where the Aravallis were present in that region. So here, if you talk about the Aravallis, if let's say this is the alignment of the Aravallis in general, let's suppose, right? At one point of time, it is estimated that Aravallis would extend very much to the present day region of Haridwar also. It was estimated that at one point of time, the Aravallis would be continuous from the southern part of Rajasthan, all the way crossing Delhi, all the way into the region of Haridwar. That was a part of the ancient fold. Few of the regions, in fact, within these Aravallis, they also end up showing evidences of a caldera. So imagine the kind of eventful past that this region has and how old this region will be. Now, all these have been weathered and eroded over a period of time. Once the endogenic forces they stop acting, then it is only the erosional and the weathering forces which are present. There is no counterbalance and everything is eroded. Now they have been reduced to a kind of a residual hill or a residual mountain. In fact, as you move between Rajasthan and as you move from the region of, let's say, Manesar, or even furthermore, if let's say if you come from the area of Pataudi, then from the region of Gurugram into Delhi, you'll find few of the relics of not what is a hill anymore. It is a kind of a ridge. That is also now what is referred to as the Aravali Ridge Line, which is said to exist all the way from Delhi to Haridwar. That is nothing but a remnant of an ancient Aravali Hills or Aravali Mountains, which used to be very dominant in that region. But the decline in the height of the Aravalis began long before the movement of the Indian plate started happening towards north. Right? Aravalis are very, very old. So, as the Indian plate was about to collide, water entered in the water of the Tethys Sea is said to have entered into this particular entire region. And you had a kind of a shallow sea which was created here. Later on, the water retrenched and retreated and drained out. But what was left was a kind of a deposit which was present from earlier, carried out by the rivers. On top of that, you had marine life functioning here for a considerable amount of time, and then the water retreated. So that is why even today, you'll find fossil fuel deposits in the region of the Shekhawati region of Rajasthan, western part of Rajasthan, Bikaner, Jaisalmer, the entire belt has got significant amount of crude oil and natural gas. That is because this was underwater. Now, the reason that the Aravalis are a desert is because of the alignment or reason why the Thar is a desert, not Aravalis. The reason why the western part of Rajasthan is a desert is ascribable to the alignment and the orientation of the Aravalis. Why? Because these Aravalis, they are parallel to the Arabian Sea branch of monsoon. The Arabian Sea branch of monsoon, they simply come by and they move through. They will cause some amount of rainfall. In the southern part of the Aravali ranges, they will receive some amount of rainfall, but otherwise, they simply move through. And then from the east, you have the Bay of Bengal branch of monsoon. And this Bay of Bengal branch of monsoon would hit the mountains, the hills, and they would cause rainfall here only in the eastern part of Rajasthan. So, because of this, the western part of Rajasthan continues to remain a desert. Okay, so if you have to ascribe a reason for the desert existence, so western Rajasthan as a desert, yeah, Arabian Sea branches are parallel. Is parallel to the Aravalis, so hence nothing stopping them, right? And then you have Bay of Bengal branch getting stopped at the eastern end of Aravalis. And hence the western end of the Aravalis or the western part of Rajasthan will be a desertified area or a rain shadow area. Had the orientation or alignment of the Aravali's been even slightly different, the conditions of rain would have been very different. Let's suppose if the Aravali's would have been, let's say, in this shape, the entirety of Rajasthan might have received rainfall. But in that case, the so called green bowls of India, Punjab, Haryana, Western UP, all of them would have been a complete dry desert, right? So that is where many of the geographers, they always have this very famous quotations that Rajasthan sacrifices itself for the greenery of the north, right? So if Rajasthan would not have been a desert, the northern area would have been a desert. So that is basically the formation of the Thar Desert, the reason for why the region of Thar is considered to be a desert. It has not always been so. And now we know why you also end up finding crude oil or fossil fuel in the region of the Thar Desert. Okay? So, it lies to the northwest of the Aravali Hills. It is a land of undulating topography dotted with longitudinal dunes and barchans. Low rainfall, below 15 centimeter per year, and it has basically got an arid climate. This is also what is referred to as Marusthali. Okay, now that is in local lingo. Now here you'll find various different desert features, or the features that you find in the many of the desert areas across the globe. So that is something that you will find here also: mushroom table rocks, shifting dunes, barchans, all of them, oasis, all of them are common. Okay, what is oasis? When we talk about an oasis, what is an oasis? So in the middle of the desert, oftentimes you will find small ponds or small water hole which is present, and around it you will find a couple of trees to be start growing. So these water holes, they are created due to excessive amount of wind erosion. Sometimes when the bedrock is exposed, and let's say if the water table is very shallow, water starts penetrating through those bedrocks, and that is where it forms a small pool, which we refer to as an oasis. So oasis is to be found in the southern part of the desert, not in the western part. Okay. Now, then we come over to the other portions of the physiography. But before that, we will deal with some questions of oceanography, the previous year questions which were left unanswered. Ambika, what is the logic behind parallel Arabian Sea? What is the logic behind parallel Arabian Sea, Arabian Sea, and the reason of desertification of Rajasthan? And what is the logic of Bay of Bengal? Okay, fair enough. So, why will a region receive rainfall? If you think about it, we have talked about it in very significant detail last week when we talked about the entire concept of why monsoon causes rainfall, what are the aspects which bring monsoonal rainfall, etc. So, we had talked about the fact that monsoonal rainfall generally in India are caused because of orographic conditions. Orographic conditions, they are significantly responsible. That is, a mountain will block them. Now, if let's say when we say the Arabian Sea branch of monsoon, when they are moving parallel with the Aravallis, what is there to block them? They will be blocked by the Himalayan ranges, and hence they will cause rainfall in this area. Here, the southern part of the Aravallis has got this kind of an alignment, a kind of a blockage of sorts. That is why southern part of Rajasthan does receive some rainfall. The concept of the Bay of Bengal branch, basically, if you will observe, that when you have the Bay of Bengal branch of monsoon which is moving in, it will hit the eastern part of the Aravallis. It will cause orographic rainfall in that region. But the western part of Rajasthan, that will lie in the leeward side, rain shadow zone. Are we aware of that concept, or are we not aware of that concept? We are aware? Okay. So that is where on the leeward side, on the rain shadow zone, you won't have any rainfall in this entire portion. Whereas the Bay of Bengal branch of monsoon will be able to cause rainfall only here. So that is why the southern and the eastern part of Rajasthan, they receive rainfall, whereas the rest of the Rajasthan is dry because of the shape of the Aravali's, the alignment of the Aravali's. Is that understood, Ambika? Or is that the doubt that you were asking, or were you asking a separate doubt altogether? Okay, good. Yes, Pranay, that is the concept involved here. And Ajit, like Indus civilization, why there is no civilization like Ganga and Brahmaputra? So Brahmaputra, we don't have any evidences till now, but we cannot as of now claim that you won't have any kind of civilizational evidence to be found there. You never know. But in the case of Brahmaputra and the region of Ganga, the entire region was very densely forested. In fact, even in the recorded history, when you read about the Mahajanpadas, the ancient period, in ancient history, when you read about the 5th and the 6th century BC, about the time of the Mahajanpadas, what do you talk about in there? That because the iron had come into existence in utility, that is where people were able to clear the forest in the region of the Magad plains, and that is where the entire Magadhan settlement started coming into existence. Otherwise, these were so densely forested that people would not come there, right? So I am sure you would have read that in ancient history. Next time when you read it, associate it with a geographical feature. Sai Babu, second point in Indian desert. It is this portion, Sai Babu. Is it this portion that you are having a doubt? Longitudinal dunes. So we have studied the sand dunes, right? How many of us have no clue that we have studied sand dunes or not? We have studied it to specify it in module 5, that is in the portion of landforms. We had observed or we had studied about the depositional features created by landforms, right? There we had studied about the different types of dunes. We had the transverse dunes, we had the longitudinal dunes, you had the star shaped dunes, you had the barchans which were created. So barchans basically are which kind of dunes? Crescent shaped dunes. Longitudinal dunes where the winds are coming from. Yes, very good. So longitudinal dunes, winds are coming from both sides. So you have a kind of a dune shaped formation which is longitudinal in that extent. Sai, have we not revised the portion of geomorphology? Be very honest. So longitudinal dunes, this is where winds will be coming here from both sides, accumulating and dropping the sediment, or rather the sand. Barchans are basically a crescent-shaped dune where from center some portion would have subsided. So a barchan, typical barchan, appears from a top view to look something like this. And from a side view, it will give you an appearance like this. That is a barchan. Has that not been revised, Sai? Be honest. Or is it something that you have heard for the first time? Was this the doubt, or was your doubt something else? Benita, what was the vegetation of Western Rajasthan before? So it is estimated that this would have had the presence of tropical vegetation. Okay, it was a region of tropical vegetation because there was vegetation present long time before it reached equator. So that is what is the estimate, right? And that is where it is estimated that now, because we have not found many deposits of them, many different evidences of them, an evidence was found around a couple of years back, and that indicated the presence of dense equatorial vegetation which was submerged for a very long period of time. That was the evidence found some time back. Eastern part of Aravali receive rainfall due to Bay of Bengal branch. Why southern part receive rainfall? Southern part, if you take a look at the shape of the Aravalis, Aarti, the shape of the Aravalis are slightly different in the sense that it is not simple north to south. It is basically, you will find that in the southern portion, there is a kind of a denture like this. There's a bend of sorts like this. So this is what provides a kind of an orographic uplift for the Arabian Sea branch of monsoon, which causes rainfall in that. Is that understood? Okay. Any other doubts that we have? Feel free to ask. Don't worry. Regardless of the fact that whether you have revised it or not, we won't discriminate. So please feel free to ask a question if you have. But I will ask you the question that if you have revised or not, that is something that I will ask. So many of us, I guess, have not revised the portion that we have studied. How many of us are present here who have not at all taken a look into what was climatology, geomorphology? It was a long time back. Why to concern ourselves with that? Any of us bold enough to admit or honest enough? Okay, good, fair enough. Let us then move ahead with the questions. So consider the following statements. In the tropical zone, the western section of the oceans are warmer than the eastern sections owing to the influence of trade winds. Read the statement carefully. In the temperate zone, westerlies make the eastern section of the oceans warmer than the western sections. I will give you 1 minute time window. Which of the statement given above is or are correct? Read the statements carefully. Apply your logic. Shubhajit, okay, as of now, read the question, Shubhajit, carefully. I'll get back to you. What is cos or chos? Hmm. Quite a significant majority have given the incorrect answer. So many of you have given one only, two only. Okay. So that means the question statement has not been read carefully. Let's suppose this is the planet. Let's suppose this is the region of equator. Now, first of all, understand the difference between western section of oceans, western section of continents. So let's suppose you have a continental landmass which is present here. Okay. You have a continental landmass which is, let's suppose, present here. Now, this is your Tropic of Cancer. Okay. Now, the first statement is in the tropical zone within the tropics, the western section of the oceans are warmer than the eastern section. So here, if this is the ocean, the entire region, let's suppose this is an ocean. So the western section of ocean will be which portion? Here, this portion. Now the question statement is saying that it will be warmer. Now in the tropical region, what do we have? We have the presence of trade winds. Trade winds are moving in which direction? Like this. So in the western section of ocean, what phenomena will be observed in the western section of the oceans? Let me know. All those who have marked it incorrect. La Nina, how come La Nina? La Nina is a very unique phenomenon observed only in the region of Pacific, Western Pacific. Okay. So here you will come across the condition of, very good, downwelling. Downwelling. Now, what does downwelling do? Downwelling will end up increasing the temperature conditions. Always the sea surface temperature increases due to downwelling. Sea surface temperature increases. So, in the tropical zone, western section of the oceans are warmer than the eastern sections. Because in eastern section, what will happen in this region as the winds are moving offshore? What will be observed in the eastern section of the oceans? Upwelling, right? So upwelling brings colder waters. Downwelling means accumulation of warmer waters. So this statement will be correct. Second statement, in the temperate zone, the westerlies make the eastern section of the oceans warmer. Eastern section of the ocean will be this portion. So the eastern section of the oceans become warmer than the western section. So in the western section now, the westerlies will be creating upwelling. Here they will be creating downwelling. So this is also going to be correct. So the answer is going to be C, both 1 and 2. Is that understood? Everyone, any doubt that you have, Prashant, let me know. Any doubt that we have in this area? Good. Benita, see, that logic that you have followed about the occurrence of rainfall, that logic will come into play if, let's say, the eastern and the western section of the continents, their temperature is counted for. But whenever you have the temperature of the oceans, always try to look at whether an oceanic circulation is being talked about. If not, if only the influence of the wind, then either upwelling or downwelling. And here, many of you, as is the case with many of the candidates, majority of the candidates, they commit mistake in identifying the eastern section of the oceans and the eastern section of the continents. They end up confusing in that. And that is why UPSC asks these kinds of, because if you understand the logic behind it, is a very simple question. It is whether you are able to understand the logic in that high pressure, where maybe before this, you would have faced a question about, let's say, Indian economy or a repo rate, and your mind would be in a different scenario after. Before that, maybe you would have faced a question about a protected area, and then suddenly you come across this question, are you able to concentrate enough? That is the entire ploy of prelims examination. If you are able to concentrate for each and every question, if you are able to manage your tension level for each and every question, trust me, many of the questions which otherwise you commit as mistake, you would be able to commit as, or you would be able to attempt it as a correct question. Okay. uh okay, yes, Prashant, the eastern section of the continents you want to understand, or you want to understand the entire eastern section? So please understand here, when we talk about eastern section only. Okay. So when we talk about this region, you have the ocean surrounded by continents. Okay. Now, this will be the western part of the continent. This will be the western part of the continent. This will be the eastern part of this particular continent. But when we consider the ocean as a reference point, this will be the western part of the ocean. This will be the eastern part of the ocean. So when you have the trade winds which are blowing here, these trade winds will cause upwelling in this area. Upwelling reduces temperature. Water from the lower region comes up. So that will be cooler. Here in the temperate regions, you have the trade wind, the westerlies which are going to accumulate water. Excuse me. So westerlies are going to accumulate water here. That is where you will experience downwelling, right? So that is why the eastern portion of the oceans, they will indicate different behavior. Is that understood? Now, one question, Shubhajit, you had asked about the chos or the kos. So you have got an answer to that in the SMEs. They have provided you the answer. Just to again reinforce the same point which was made, basically, the southern slope of the Shivaliks in the region of Punjab and Himachal Pradesh, the Punjab Himachal Himalayas, the southern slope of the Shivalik is very, very steep. So if you take a look at it from the side perspective, the hogback topography of the Himalayas, they exhibit this kind of a shape. Let's say we analyze the southern slope. The southern slope will appear somewhat like this. Now, because there will be a significant strong orographic uplift, it will cause very heavy rainfall. Whenever the rainfall is caused, you will have many small seasonal streams which come into existence. They have not been in existence before, but they will come into existence and they will crisscross the entire slope, eroding this entire region. So these seasonal streams, basically, that is what you have as creation of course. Okay. Now, then an easy question. After a difficult question, let's have an easy question to boost your morale. So, the most important fishing grounds of the world are located in where? Yes, this is a pure confidence boosting kind of a question. So, and when you come across these questions in the prelims paper, it brightens up your face like anything. So, good, very good. Majority of us have given the correct answer. So, ideal fishing grounds where you have warm and cold oceanic current when they end up meeting, that is where the fish population is going to be very high. Now, tides occur in the ocean and the seas due to which of the following? Gravitational force of the sun, gravitational force of the moon, centrifugal force of the earth. So, tides are caused because of which of the following? This also, I expect majority of you to get it correct. Okay, please get it correct. Good. So here, gravitational force of the sun and the moon, as well as the centrifugal force, both of them end up representing the tidal generating force. So the answer is going to be D, 1, 2, and 3. Okay. Then here we have a question. Most of the world's coral reefs are in tropical waters. More than one third of the world's reefs are located in territories of Australia, Indonesia, and Philippines. Coral reefs host far more animal phyla than those hosted by the tropical rainforest. Which of them is or are correct? Good. So here you have significant majority of you given the correct answer. Actually, the first and the second statement, they are almost indisputable. So Most of the world coral reefs are formed in tropical waters. That is where the warmer waters are prevalent. Now, more than one third of the coral reefs are situated in the region of Australia, Indonesia, Philippines. This is what is also referred to as what? This region is also what is referred to as the coral triangle. So that is where you will find a significant amount of coral population. Then coral reefs, they host far more animal phyla as hosted by the tropical rainforest. This is regarded as incorrect because overall in the animal or in the forest region, you have significant, even the insect population that you count, that in itself will be much more significantly. So that is where the third statement is going to be incorrect. Then after that, at one place in India, now, this is something that we had discussed significantly. So, at one place in India, if you stand on the seashore and watch the sea, look at the statement, read the statement carefully. Okay, let me know the answer. I'll give you 1 minute to read the statement. Yes, Anshu, this is a PYQ. What else do you think this is? This is a previous year question that we are discussing. Good. So, Chandipur in Odisha, that is where we observe this. Okay. Now, then the questions which have been asked. So here look at the repetition of the question from oceanography. So in geomorphology and oceanography, understand that UPSC has got a very limited scope. UPSC will end up asking the same topics again and again and in a very direct manner. It is in the portion of climatology where UPSC can be very creative, end up having terms which you might end up getting very confused with. So here look at the question. Explain the factors responsible for the origin of ocean currents. How do they influence the regional climate, fishing, and navigation? And the other part, or basically the other question which was asked in a different year, what are the forces that influence ocean currents? Describe their role in fishing industry of the world. This was asked last year in 2022. So when you get this kind of a question, how do you address this question? So in the introduction part, you'll write about what? You'll write about what do you understand by ocean current, right? So you'll write what is ocean current. You'll talk about that. Now, ocean currents are a defined movement of water in a predefined path or a regular movement of water continuously in a predefined path occurring across the oceans, carrying water from a lower latitude to a higher latitude and vice versa, leading to the distribution and the transfer of heat as well as mixing of nutrients across the oceanic waters. Simple enough. Now, these ocean currents are dependent or are influenced by various factors. That is the end of introduction. In the body part, talk about the various different factors. Draw the diagram. Schematic diagram is an absolute must. And then, how do they influence the regional climate? For example, regional climate, first of all, they can influence the temperature of an area. Warm ocean current in the North Atlantic warms up that region. Ocean currents can bring about even atmospheric conditions like El Nino, La Nina into play. Then they can create deserts in the western parts of the continents. So that is how climatic conditions are influenced. Fishing, meeting of warm and cold ocean currents. Give the example Labrador as well as Gulf Stream, and then Kuroshio, Oyashio. These are your good conditions of fishing, right? Advection fog is another kind of advection fog that you have, is created where you have warm and cold ocean currents move. So that is where again regional climate is influenced. Then the in many of the areas, the ocean currents, the meeting of the warm and the cold ocean currents also brings about the development of a front, and that brings its associated climatic conditions. So these are few of the areas that you can focus upon. Try to think about as many different portions of climatology that you have studied and think about it. Can an ocean current lead to creation of any of these events? Can ocean current, let's say, alter a temperate cyclone? Maybe, if you have a cold and a warm ocean current meeting. So like that, if you just scan through the portion that you have studied in your mind, you'll be able to come across with many creative points. Every candidate who is going to write for the mains examination, they will be aware of the basic simple portions like fishing and navigation. Everybody would be aware. It is in these areas where you have the scope for creativity and the scope for creating a difference. Can they lead to cyclones? Not significantly in the case of tropical, no. But in the case of temperate, sometimes they can lead to the frontal formation to be exaggerated. So that is where they can. Coral reefs, third point is basically coral reefs host far more animal phyla. I am sure this phyla word is not understood. Phyla stands for phylum. So basically, number far more animal species as compared to tropical rainforest. So that is basically tropical rainforest will have large number of animal species that they inhabit. Then another question of climatology that we had said we'll discuss after we have studied oceanography. So tropical cyclones are largely defined to South China Sea, Bay of Bengal, and Gulf of Mexico. Why? So here we have the water body surrounded by landmass, a significant heating. Large number of rivers, they come in for this in these areas, they drain into these areas, they cause a stratification of water. Large rivers come in and drain into this area. Now trade winds, they drain or they blow through this. So in all these areas you have downwelling, and that is why here what do you have? You have the condition of warmer waters. All these factors you can highlight. Account for variation in oceanic salinity and discuss its multidimensional effects. Oceanic salinity. Why is it that oceanic salinity will vary? Give the detailed description that how in areas such as Mediterranean, Red Sea, it can be very high. How in the region of the Arctic or the polar region, it can be low and high depending upon the season that we are in. Across the river mouths, what can be the salinity conditions? Across the tropical areas, why salinity condition is high? So all those factors about the variations you will talk about. Now, here it is simply saying variations in ocean salinity. It does not mention whether it is horizontal or vertical variation that we are talking about. So what is the correct approach? Discuss both of them. Discuss both horizontal as well as vertical. Okay? And the multidimensional effects, that is thermohaline circulation, availability of various species is also impacted by the saline condition, etc. All of that you can mention. Okay, is that clear? Good. So now we will come to the second portion of the physiography, that is we will talk about the Peninsula Plateau. But before that, we'll take a break here, and we'll take a break and we'll get back. So 15 minutes, we take a break, and we'll be back in 15 minutes. Okay? A confirmation about the audio, please. If the audio is clear and available, kindly confirm the same. Thank you. So, Ambika, you have a question in doubt in the first PYQ that we discussed. What is the doubt that you have? Kindly ask the question. So basically understand in this question, the aspect is to understand where upwelling and downwelling is happening. And wherever you have the onshore wind, there you will have downwelling. Onshore wind always are associated with downwelling. Okay. And offshore winds, wherever you will have offshore winds, they will end up creating upwelling. Okay. So now take a look at the wind movement and think about it. Where is it that downwelling is happening? Where is it that upwelling is happening? You will get a clue. Downwelling will increase the sea surface temperature and upwelling will reduce the sea surface temperature. Okay. Is that clear? So now we move ahead with the portion of, yes, Vishal, that is correct. Now we move ahead to the portion of the physiography where we talk about the peninsular plateau. Now, peninsular plateau, why is it referred to as peninsular plateau? So it is referred to as, first of all, when we talk about the peninsula. So peninsula is that kind of a landmass where you have a triangular shape almost associated, where water surrounds it from three sides. That is what is peninsula. And plateau, because it is in that portion of India that you have a plateau formation. Okay, Anshu, you have a question. How the triangular shape of the Bay of Fundy results in high tide, or is it the high tide due to the wide continental shelf? So the high tide in the region of Bay of Fundy, basically, Anshu, that is a product, some product of multiple things. First of all, a wider continental shelf, and secondly, water is channelized between the mainland and Nova Scotia. If you look at the map around region of Bay of Fundy, it is between Nova Scotia and the mainland. So that is where the water is channelized into a narrow portion which has got a wide continental shelf. That is why the tidal variations are quite significant, because both of these, they end up adding together. Okay, is that clear? Now we talk about the formation of the peninsular plateau. What is a plateau? Plateau is basically a flat tableland like structure having slopes on the sides. That is a plateau. Now here, the Peninsula Plateau has been created as a result of volcanic eruption. Volcanic eruption which has happened long time back, millions and billions of years ago. So here, you will observe that immediately to the south of the plain region, that is immediately to the south of the northern plains, we have the existence of this very extensive and a very old plateau region, consisted majorly of the igneous and metamorphic rocks. Right. So it is one of the oldest landforms created on Earth, and easily the oldest landform which is created in India. And here it has got a volcanic origin. So that is where you have the deposits, very thick deposits of the volcanic igneous rocks which are to be found in this area. Now, over a period of time, because this landmass is so very old, that means significant proportion of the top area has been eroded or has been weathered down. Now, when a significant proportion has been eroded or weathered down, so the lower regions, they are now the surface that we take a look at, or the surface that we observe, that is basically the lower regions which have been eroded significantly. That is why it is in this area where you will find a predominance and a majority of mineral deposits to be found. So the minerals lying deep inside the rocks now have been exposed and can now be extracted. It is because of this that the peninsular region is to be found to be very, very rich in the deposits of minerals. And here also it is not as if entirety of peninsular plateau is going to be rich in minerals. You have the older areas, the older regions, which have undergone significant amount of changes and significant amount of weathering and erosion. That is where the minerals now stand exposed, and that is now where you will find the presence or availability of minerals. Okay. Utkarsh, can we say it formed a shield volcano and afterward through erosion it formed a shape? No. Let us move ahead slowly and steadily, and let us try to understand how this peninsular plateau came into existence. Okay. So here, before moving ahead into the aspect of the creation and the formation of the entirety of the peninsular plateau, here, let us introduce ourselves to a particular term. So, when we talk about all these continental land masses, all these large continents that we come across, what do you think how they have been would have been created? Would it have been a situation where the entirety of the Eurasian landmass or the entirety of the Indian landmass would have been created at one go? Absolutely not. So, how is it that these land masses are created? Initially, you have small building blocks, and these small building blocks they eventually get together. So, small land masses are created individually and in an isolated portion, and eventually they will get together due to the deposits that are carried out and so on, and it forms a continuous landmass or a continental landmass. So, these small land masses or land blocks, which lead to the building of the large continents in itself or large land masses in itself, that is referred to as a craton. So, cratons, they are referred to as building blocks of continents. These small individual building blocks, they get together to form the very large continent. Now, even in the case of the Peninsular Plateau, the formation did not happen at once. It happened in the formation or in the form of cratons. So initially, you had the presence and the formation or the creation of this particular area, what is referred to as the Chota Nagpur craton, that was created. Then, and how was it created? Due to volcanic eruption. Then, you also had the creation of this craton, that is the Bastar craton. Okay, this came into existence. These were still away from each other, these were not joined. And then you had the formation of the craton in the region of Karnataka. What is the Karnataka plateau or the Karnataka craton or the Dharwar craton? Then after that, we also had simultaneously the creation of land masses here in the region of Bundelkhand, and that is where you also had the formation of the Aravalis taking place. So like that, you had different cratons which were created. This was Chota Nagpur craton. This was the Bundelkhand craton. This is the Dharwad or the Karnataka plateau craton. Then after that, this was the region of the Bundelkhand and the Aravalis. Okay, so these individual blocks were created. These individual blocks came into existence. And it is estimated that these have happened billions of years ago, around 1 to 2 billion years ago. That is where these have been formed. Now, such a long time period back, once you have these getting created, that means You will have the seasonal streams or the rivers which would have drained in that area. Historically, once the landmass gets into existence, the rivers they follow, they also start draining that area, isn't it? So these rivers, which would originate from the region, they would drain down, they would erode these substances from here, and they would deposit them in between. And that is how you had the sedimentary deposits which were carried out in that entire region. In that entire region, you had significant amount of deposits. Now, later on, many of these sedimentary deposits got converted into sedimentary rocks and eventually, due to pressure, into metamorphic rocks. Okay, many of them got created under or got the existence of metamorphic rocks. So that is where initially these were created. You had minor eruptions and minor deposits which also formed a brief landmass in this area. So the earliest of the Indian landmass included of a land portion all the way like this. Okay, that was the ancient Indian landmass. Now here you will observe that the Bundelkhand and the Chota Nagpur Plateau Craton, both of them, they underwent a collision in the early days. And that is when you had the creation of small folds here in the form of the Garjat hills that you still find in the region of Odisha. These were the result of the folds. Similarly, these, as they would interact with the nearby oceans, also had the formation of few of the mountains across the coastline. Now, it is a different matter now that after billions of years, these once mighty mountains, they have been reduced to very small hills that we regard as the Eastern Ghats. But all of these were created along with the cratons. Now, here, understand how it spanned out. So here, basically, both craton are named as Bundelkhand. Which craton is named as Bundelkhand? It is here. The Bundelkhand region is between the area of northern Madhya Pradesh and southern Uttar Pradesh. That is the region of the Bundelkhand craton. Okay. So the earliest Indian landmass had a shape somewhat like this. Okay. Under Chota Nagpur, the craton in Bundelkhand. No, Bundelkhand is here. Chota Nagpur craton is here. Both of them are different. Okay, both of them are different. This is Chota Nagpur craton here. Oh, this is, I have referred here Bundelkhand craton. Pardon me for that. Thank you for pointing it out. This is actually the Bastar craton. This is actually the Bastar craton. Thanks for pointing that out, Shubhajit. So that is how you had the creation of these individual land masses. And these individual land masses would go on depositing materials in between, forming a landmass in between, and forming a continuity. Now, once the Indian landmass had been created, it was dominated by igneous rocks in significant proportion, sedimentary rocks in certain areas, and that would be in existence. But we have talked about the fact that Indian plate moved north. As it separated from Gondwana land, Indian plate started moving northwards. So here, if you can imagine that aspect, let's suppose if this is the planet, right? Let's suppose if this is the region of equator, Indian landmass started moving away from the region of the polar area. It started moving. Now, as it came over the region of the Reunion Islands, the western portion of India, that lied over the region of Reunion Islands. Now, Reunion Islands is a volcanic hotspot. And when Indian landmass was over there, Reunion Island is still a region of active volcanism. So, around 80 to 90 million years back, when the Indian landmass was very much above the region of the Reunion Islands, at that point of time, what happened was that there was a massive eruption. And the eruption, which did not happen at once, you had multiple different eruptions, phases of eruptions, which continued for millions of years. Now, here, hundreds and thousands of years at least. Now, you have to understand that 100,000 years is a long time period. It is not a short time period. It is a very long time period. And in that point of time, from the Reunion Islands, you had the emergence of what kind of lava? So, Reunion Island hotspot. Here, you had the flow of basaltic lava. Now, basaltic lava, does it have the property to flow easily, or do you think it is viscous and doesn't flow easily? Let me see. Okay, Pranay, good. Anyone else? If you have any clue before searching on Google. Good, Benita. Anshu, correct. Utkarsh, correct. So basically, basaltic lava ends up flowing very, very easily. It has got a fluidity in terms of flow. Viscosity is very low. So this spreads over a large distance. So when the basaltic lava flows easily, it spreads up just like fluid. It will spread over a large distance. And then after that, let's say for the next 10,000, 20,000 years, no eruption has taken place. So obviously in the next 20,000 or 1 lakh years, you will have many small seasonal streams, accumulation of water, etc., which would have happened. Then again, after let's say 1 lakh years, again another set of eruption happened. And that eruption basically again flowed easily and formed another layer, trapping water and other resources which have been developed in between. Then again, you had a time interval. And again, an eruption meant a spread of materials again. It is estimated that during the entire time period that India was over the Reunion Island hotspot, the volcanic eruption ejected close to around 1.5 lakh kilometer cube of molten materials. Let that figure sink in for a bit. 1.5 lakh kilometer cube of molten materials were thrown out, expelled by the Reunion Island hotspot for the entire duration, for the few million years that Indian landmass was over the region of Reunion Islands. And this continued to spread. Eventually, this formed multiple different layers, trapping water in between. Right. Now, at the edges in general, what do you observe? You will observe at the edges the formation of a step-like feature. Here, a step-like feature on the edges is observed. Now, this step-like feature, that is also regarded as trepen. So this is regarded as the name, ideal name for this is trepen. And from here, you have the term which was derived, that is traps. And hence, this is the region which is referred to as the Deccan Traps. And the Deccan Traps, the naming is done because of the step-like feature that you find at the edges of this humongous volcanic eruption. Now, it happened as long as India was there, above the Reunion Islands. Now, as India moved northwards, this volcanic eruption stopped. But in the meanwhile, you had significant series of these deposits, igneous rocks that have been formed in multiple layers in many of the regions. It is estimated that multi-kilometer thick of these deposits have occurred, have happened. Now imagine a situation, if I give you a situation here, let's suppose for around 5 to 7 to 8, 10 thousand years or 100,000 years, all this basic eruption and deposition and cooling down of lava has happened, forming very hard igneous rocks. Now, if let's suppose this is the source where you have the volcanic vent attached to a magma chamber in asthenosphere, let's suppose. Now, for the molten materials to come up, do you think will it will be an easy process, or do you think it will be a difficult process for the molten materials to come up? What do you think? Will it be easy process or will it be difficult? Correct. It will be a difficult process because on top of it you have kilometers thick of lava deposits which have now converted into very hard igneous rocks. So it will be very, very difficult for the molten materials to come up after that. Now that is where in the final stages, when India was still above the region of the Reunion Islands, it is said that in the final stages, you had a massive burst of volcanic material which wanted to come up. But if this is the landmass, which has got significant kilometers thick of igneous rocks, those materials could not break through. But what they ended up doing was they ended up entering into the crustal region and solidifying in the portion. And when that happened, observe if this is the landmass, let's suppose, consider the palm of my hand as the landmass. Now, if the molten materials, rather than being able to break through the surface, they have managed to just puncture the crust and they have solidified. What happens? They have solidified here. Now, the landmass that is created, earlier it was like this, now it has got a slope, isn't it? This is the reason why in the peninsular part of the country, you'll find that a general slope is from west to east because these materials, when they could not come up, they simply formed a kind of a large intrusive formation, and that brought about the slope. So this is the reason why in the peninsular India, the majority of the rivers, they originate from the west, but they drain all the way into the east because the slope of the land is from west to east. Okay? Now, moving on further. So as the Indian landmass was coming up and moved away from the Reunion Islands, then it did not experience any volcanic eruption. And here, basically, this was the broader shape which was associated. Now, obviously, in these volcanic landforms, you have various different types of compression, tension, etc. And when you have very hard rocks, when you tend to compress or stretch them, rather than getting deformed, they develop crack-like features. So you had various fault lines and cracks, the weaker areas on the crust of the Indian landmass which were in existence. But observe the shape here. The shape is particularly unique, not what you associate with the Peninsula Plateau. Reunion Islands, they are currently situated where? They are presently situated in the same region where they have always been. So the volcanic hotspot that I am talking about, that has led to the formation of Reunion Islands right now. So locate the Reunion Islands. It is present in the southern part of Indian Ocean, near the region of Madagascar, that is to the east, northeastern part of Madagascar. You'll still find the Reunion Islands. That is a volcanic hotspot which has been erupting for millions of years altogether. So it was those Reunion Island hotspot which had created the entirety. This entire portion was dominated by this flood basalt. Why is it referred to as a flood basalt? Because it spreads like water, it floods the entire region. So this is one of the reasons why, again, Indian landmass's crustal portion started becoming heavier than what it was. So here you had the entire eruption due to the Reunion Island. So whatever was the landmass before that, that was completely overshadowed by these deposits. If ever you get an opportunity to travel, let's say between Mumbai to Nashik or Mumbai to Pune, let's say Mumbai to Nashik, now that travel or that journey moves through the gaps in the Western Ghats. You have the entire Kasara Ghat section, etc., which is one of those areas in India where the railway line has got a very steep gradient. So if you ever get to travel either by rail or by road, observe your surrounding region. What appear to be as hills right now, here, if you observe carefully, they will exhibit a kind of a very thick layering, very thick and very broad layering. And that is what tells you how that region would have experienced series of that flood basaltic deposits. So the next time that you are visiting that region, do keep do keep an eye out for these kind of formations. Okay, so it was that Reunion Island which was responsible for the creation of these Deccan traps. These were your Deccan traps. Deccan traps. And also, over a period of time, many of these areas, many of these small cratonic areas, they were colliding with each other, with the nearby sedimentary masses, etc. And they were creating the small hills, Kaimur Hills, and so on. It is this region of flood basalt which experienced significant amount of crack formation due to the movement. And that is where you had the formation of the block mountains of Vindhyas and Satpuras. But still, the Indian landmass was very different from the present day shape. And it marched ahead in the region of the Eurasian plate. This was the shape of the Eurasian plate with the minor Burmese plate on this side. Now, when this collision happened, whenever you have two large solids which collide, the many weaker areas which are present, the weaker areas, they develop a large crack, right? So you had the development of this crack happening in many areas across the region of the western coastline. A large crack emerged. Across this area, you had a very large crack which emerged. Now, these cracks, they are not incomplete. They cover the entirety of the landmass. So in that situation, when that collision happened and these cracks developed, now these land masses, they slowly and steadily began collapsing. They started sinking and a subsidence happened. So that is where in this area, in this entirety of the portion, there was subsidence. There was sinking. Here also, there was sinking of the landmass. And that is when the present day shape was created. This is the reason why, if you observe the western coastline of the country, observe that the shelf area is particularly wider. So at one point of time, what you see as the shelf area in western coast, it is very, very wide. But what have we studied in the portion of continental shelf? that if you have steep slope on the coastline, the shelf is narrow. In the case of Western Ghats, we have a steep slope, but the shelf is very wide. Why? Because that portion has went underwater. That is still present under the region of Arabian Sea, forming that wide continental shelf. And this was created around 60 million years back when you had the entire region subsiding. Now, around the time of formation of the Himalayas, it is also postulated, it is also estimated by many of the geologists and geographers, for example, Koteshwaram and all. They have given a distinct theory that look, at that point of time, still for some duration of few lakh years and maybe a couple of million years also, the peninsular landmass was still very much connected to the Shillong and Meghalaya plateau. So the rivers, the mighty rivers of the Himalayas, they would basically end up accumulating water in that entire four deep which was created in front of the Himalayas. They would end up accumulating water, forming a kind of a shallow sea almost. But then, this portion, the present day region of West Bengal and Bangladesh, that developed a crack and that simply went down. And when it went down, it created a gap in between the extent of the peninsular plateau here and the peninsular plateau portion which was present earlier. A gap was created. This gap which was created, this is also what is referred to as Raj Mahal, Garo Gap, or what is also referred to as the Malda Gap, because it is observed in the Malda region of West Bengal. Right, and Raj Mahal Hills, this is the Raj Mahal Hills of Chota Nagpur Plateau, and this is the Garo region. So that is why Raj Mahal Garo Gap or Malda Gap. Now, when this Malda Gap or the Raj Mahal Garo Gap was created, immediately it meant that all the rivers which were accumulating, which were draining in that region, they found a low-lying depression to flow into. And that is when it is said that rivers such as Brahmaputra and Ganga, they started taking a southward turn here and they started draining into the region of Bay of Bengal. But at that point of time, it is said that this region significantly was underwater. But slowly and steadily, deposits that started to happen. And these deposits, carried by the rivers over a period of millions of years, they have created tens of millions of years. They have created the very fertile, very thick layer of sedimentary deposits in the present day region, which we refer to as Bangladesh, and in the region of the plain area of West Bengal. And this is the reason why the Western Ghats, this particular region of the Western Ghats is referred to as an escarpment. It is not a mountain. It is not referred to as a hill. Western Ghats, they are referred to as what? Western Ghats is referred to as an escarpment. Escarpment is what? We have read it in fourth module, but I fully expect us to have forgotten that by now. So escarpment is when you have a landmass and you have development of a normal fault. So one portion simply sinks down. So the resultant landmass is having a kind of a shape somewhat like this. This is what is referred to as an escarpment. Now, this is the portion which has gone underwater. And that is why the Western Ghats, they offer a very steep slope. Okay, almost steep wall-like feature is to be observed in the Western Ghats. So the next time that you visit anywhere across the Western coastline, understand that there is a landmass underwater, which was very much present above water for a long period of time. Okay, so we have seen the formation of these individual portions. We have seen the formation of the Deccan Traps. Deccan Traps were formed the latest out of all of these. And then we have seen the formation of the Malda Garo Gap, or the Rajmahal Garo Gap, and the Malda Gap, and the fault line across the Western Ghats. So that is the origin in very brief, something that I'm sure I can give you a guarantee that you will not find in the various different textbooks that we generally refer to. Okay. So it is not as if I have known this from my childhood days. It is basically after looking through and sieving through many of the different research papers which have been submitted into that area that we are able to draw the conclusion. Some of that will be exhibited to you in the optional portions that you study, but not in so much detail. Okay. Now this will help you understand few things. For example, now if I ask you that in the entirety of the region of the Peninsular Plateau, which are the regions which are going to be very, very rich in minerals? Always the oldest of the regions. That is why high amount of mineral deposits are to be found in the Chota Nagpur Craton, or the oldest, in the Bastar Craton, Chhattisgarh, Odisha, in the Karnataka Craton, some parts of Andhra Pradesh and coastal Karnataka and coastal portion of Maharashtra, in the Bundelkhand Craton, around the region of Malwa Plateau and Aravalis. There also you'll find mineral deposits. So that helps us understand where the mineral deposits are dominant. And later, when we come to the formation of soil, this will also help us understand the kind of soil that you observe in all these areas. Okay? So basically, this Indian peninsula is formed all the way from Madagascar region. No, Indian peninsula has been created much earlier. In fact, at one point of time, even Madagascar was attached with the western coast of the Indian landmass. Madagascar was very much attached with the western coast of Indian landmass. It was immediately after Madagascar separated from India. After that, India entered into the region of the Reunion Island hotspot. That is when this flood basaltic eruption happened. Okay. And before that also, Aravallis were created much, much earlier. All the rocks that you find here, the Archean rocks that you generally find in these cratons, the older cratons, they are around 1 to 2 billion years back. This event that I'm talking about in Reunion Islands, this happened only around 80 to 90 million years back. So before that itself, lot of geomorphological features would have already happened. Okay. Is that understood? Or do we have any doubts in this? Let me know. Do we have any doubts, or is that understood? Because once you understand this, once you understand the entire process of formation, then automatically the portion of economic geography will be very easy. Why the cracks were developed? Because of the impact of collision with the Eurasian landmass. That is why the cracks started getting developed. Okay, because see, whenever two large solid objects will collide due to the impact of collision, the weaker areas will develop much more greater amount of cracks. So that is why across the coastline, the weaker areas, they develop crack. It is said that it is during that time only that you had the development of cracks, even in some portions of Maharashtra and so on. And that was later on confirmed when you had the very infamous Latur earthquake, which happened in Maharashtra, which claimed many lives, because Maharashtra was said to be, or supposed to be, a region where no earthquake possibility was there because of very thick deposits of this lava, or lava uh, and lava cooled rocks. But there also, later on, when the Latur earthquake happened, there was a further investigation. It was found out that there indeed was the formation of a crack since that point on. Garo Gap, basically, what is Garo? Garo Khasi Jayantia, you would have heard, right? The Garo Khasi Jayantia region, which is present in the region of Meghalaya. You would have heard that. Now, that was also a part of the Peninsula Plateau at one point of time. This blue line that you see, that is said to have been the earlier extent of the Peninsula Plateau. But due to the impact of the collision, a gap or a crack developed in that entire region. In this entire area, a large crack developed due to the impact of the collision. And when that large crack developed, here, this portion, which was isolated by the crack from all sides, that portion started going down. And as it went down, the rivers, they drained from that area. The Himalayan rivers, they started draining from this area, coming into the region of Bay of Bengal. And that is where deposits then followed, forming the fertile plains of Bangladesh and West Bengal. Okay. Richness of minerals in the region like Chota Nagpur is mainly because of these oceanic sedimentary deposits. Where is it that you find the oceanic sedimentary deposits, my dear friend? Only in the bordering areas of Chota Nagpur Plateau you will find some evidence of oceanic deposit. So, Chota Nagpur Plateau has not been underneath the ocean for billions of years, many billions of years. So, where do you get that conclusion from? I am interested in that. So, richness of minerals in regions of Chota Nagpur, etc., is because they are so very old, volcanic in origin. Volcanic in origin means that the magmatic material will be rich in minerals as they emerge out of surface and they get deposited. The igneous rocks, very difficult to extract minerals from, but the same igneous rocks, when they are present for millions of years, the top surface is weathered, eroded, and the bottom layers, which are generally rich in minerals, they lie closer to the surface, ready for extraction. That is why here you will find the mineral deposits. You had the development of Rift Valley in the region of Chota Nagpur Plateau also, which accentuated the deposits of the forested area in that region. And that is why this entire region also started getting rich in the coal deposits. Okay. For example, the coal beds that you find in the Chota Nagpur region and the Bastar region, that coal formation was initiated somewhere around 200 million years ago, long before the Reunion Island eruption, long before India separated from the Gondwana land. Okay? Is that understood, Aarti, Sai Babu, and Utkarsh? Or do we have any doubts? So that is about the development of and the formation of the Peninsula Plateau region. Okay. Now, the extent of the Peninsula Plateau, if you consider Delhi Ridge in the northwest, still considered to be an extension of the Aravalis, as we have talked about. The Raj Mahal Hills to the east of Chota Nagpur Plateau. It is these Raj Mahal Hills. Raj Mahal Hills are situated in this region. It is here that you have the presence of Raj Mahal Hills. Now, Raj Mahal Hills are the region where the northern plain becomes its narrowest. Okay, that is where the Raj Mahal Hills are situated. And it is beyond the Raj Mahal Hills where Ganga takes a southward bend and drains into the region of Bay of Bengal. That is why here it is referred to as the Raj Mahal Garo Gap. Okay, why gap? Because that is a gap in the extent of the Peninsula Plateau. Then the Gir ranges in the west in the region of Gujarat, the Cardamom Hills to the south, Shillong and Karbi Anglong Plateau, an extension of Peninsula Plateau. Shillong and Karbi Anglong in the region of Meghalaya. Okay, so here you have different delineations done, a broader delineation is done. So it can be divided into the Deccan Plateau, which extends across the region where that volcanic eruption had happened, significant portion of it, and also includes some portion of Karnataka Plateau and so on. Then the Central Highlands, this includes the region of the Vindhyas. To the north of the Vindhyas, you have Malwa Plateau. Then after that, let's suppose as you move immediately to the south of Vindhyas, you also have the Satpuras, by the way. Then you have the Kaimur Hills. As you come to the region of southeastern part of Uttar Pradesh and parts of Bihar, you come across Kaimur Hills. Around the region of Chhattisgarh and some parts of southern Uttar Pradesh and Madhya Pradesh, you have the presence of Baghelkhand. Okay, then you have the portion of the when we talk about the Chota Nagpur plateau, that has got the Ramgarh, Hazaribagh plateau also. Ramgarh and Hazaribagh plateau. It is a very much a part of the Chota Nagpur plateau region. This much, very much a part of Chota Nagpur. Okay, and then that is how you have the entire creation and the entire formation, which is generally observed. Okay, so this is basically in the central highlands. Deccan plateau will consist of the Telangana plateau, the large Deccan traps, the Karnataka plateau. All of that will be included in the portion of the Deccan plateau. And then you have the northeastern plateau, that is the Shillong and Karbi Anglong region. Shillong and Karbi Anglong. Okay, that is basically the various division or distinction of plateau. So that is basically the naming. So here, if I have to draw it on a map, ideally I would advise you that after this, try to open up the atlas. The atlas doesn't bite you. The atlas is not a hazardous substance. It is there for reference. So if you have an atlas, any atlas that you have, don't worry that this is the student atlas, school atlas, university atlas, latest atlas, older atlas, Oxford atlas, XYZ atlas, any atlas that you have, try to open it once. Many of us, we are afraid of looking at the atlas, that there are very childish things given here. I'm so very mature. What will I study in the atlas? But that is not the case. So when you, after this, I would suggest to you that all the physiographic divisions, now once you are aware of, open up the physical map of India, start identifying the regions in the physical map of the country. So if you talk about the physical zonation, here is where you have the Shillong and the Karbi Anglong plateau. Okay, this is where you have the Shillong and Karbi Anglong. Anglong. Then after that, here you will find the presence of Raj Mahal Hills. Raj Mahal Hills. Then after that, it is here in this entire extent, you will find the presence of Chota Nagpur, Ramgarh, and Hazaribagh plateau. Nagpur plateau. Then after that, to the south of it, you'll find the formation of the folds between the Chota Nagpur and the Bastar Craton. And that is what is the Garjat Hills of Odisha. Hills of Odisha. Then after that, you'll find in this area the prevalence of the Bastar Plateau. It extends significantly. That is where you'll find the presence of Bastar Plateau. Then after that, you'll find the prevalence of Vindhyas and the Satpuras. Vindhyas extend furthermore. So you'll find the Vindhyas and the Satpura in this region. Immediately above the Vindhyas, you'll find the presence of the black soil deposits of Malwa Plateau. It also has got black soil. That means what? This was also influenced by the volcanic eruption of flood basalt. Then, beyond that, it is in this region that you will find the region of area of Bundelkhand. And here you have the Aravali ranges. Now, Aravali ranges, they continue or reduce as small ridges all the way up till Haridwar. Okay. So here you have the Aravali hills. And here you have the Delhi ridge. If ever you visit the region of southwestern Delhi, from the region of Gurgaon, let's say if you are going to the region of southwestern Delhi, or if you are taking the route from the airport of Delhi, you will come across this kind of a scrubland, small hilly portions, not a exact a hill, but a small upraised portion. That is the Delhi ridge. And then after that, you would find the presence of, in this region, you'll find the presence of Kaimur Hills. Kaimur Hills. Then after that, in this area, spreading significantly here, you'll find the presence of Baghelkhand. Baghelkhand. Okay. Then if we come to the south, in fact, here also, you have a small upland of sorts, which is created beyond the region of the Bundelkhand. This is what is referred to as the central uplands, or what is also referred to as Madhya Bharat Pathar. This is referred to as central uplands, or what is Madhya Bharat Pathar. Pathar represents a kind of a stony plateau region. Right. Then after that, here, furthermore, you have the Deccan Traps. Extends from Maharashtra, some part of Gujarat, southern Madhya Pradesh, parts of Telangana, northern part of Karnataka. This is what is your Deccan Traps. Then after that, you have another small plateau in this region, what is also regarded as the Telangana Plateau. Telangana Plateau. Then after that, here you have the presence of the Karnataka Highlands, the Karnataka Plateau. Karnataka Plateau. Okay, so that is how the entire plateau formation, along with the map pointing, I hope it makes sense. Okay, why between Chota Nagpur Plateau and Bastar Plateau there is a presence of a fold mountain due to early collision which happened many millions of years ago. There was this collision, and it is across these areas where you will also find the formation of few. Now it is no longer a mountain or a hill, but it is regarded as a very small uprising. But generally you had at one point of time when these plateaus were created, you had the presence of hills along this entire area. It is those hills that still form the region of the Eastern Ghats. Vindhya and Satpura formation. So Vindhya and Satpuras, they are what are regarded as block mountains, right? They are basically regarded as the block mountains. So when we talk about block mountains, they have been created as a result of the block mountains are created how? So when there is compression, the central portion gets uplifted, right? So you have the creation of the block mountains in general. So that is how, as the entire region was dominated by the heavy basaltic rocks, this particular central portion of India, heavy basaltic igneous rocks were created. That is when, as the Indian plate was moving, it experienced push and pull, and that is what elevated the region of Vindhyas and Satpuras. Okay, Eastern Ghat fold, you will find the map. I'll show you in the map only, don't worry. And Malwa Plateau basically is the region immediately to the north of Vindhyas, and that is where you have the presence of black soil, and that black soil is always created when you have the presence of what? When you have the presence of basaltic lava. So it is said that even that Malwa Plateau had the presence of that igneous rock during the reunion eruption. Okay, right? Is that understood? Deccan traps basically have been created as a result of volcanic eruption, a kind of a flood basalt eruption, when you had the formation or when the Indian plate was moving over the Reunion Island hotspot in the southern Indian Ocean. That is when it erupted, and it led to series of deposits of these molten materials which solidified into basaltic rocks. And it is those basaltic rocks on the sides of these deposits, you'll find a kind of a step-like feature. From there, you have the term trepan, and hence this is the Deccan Traps. Satpura is also a block mountain. So when you take a look at kindly take a look at the fourth module that we had discussed. In the fourth module, you will come across the situation that when you have the formation of these host faults, in between, you have these depressed areas which are also referred to as rift valleys. That is why River Narmada drains through the rift valley in between these areas, Vindhyas and Satpuras. So take a look at geomorphology, you will understand. Take a look at annotation. I have marked it in the PPT in the session itself, that what are Vindhyas and what are Satpuras with the help of the example of the image. So these host faults are created. Both of these are block mountains, Vindhyas and Satpuras, and they have been created as a result of that particular uprising which had happened due to development of pressure or compressional force. Okay, right. And yes, and then area raised by Reunion Island. So all of this area in the Deccan Traps that you see, they have been created by the volcanic eruption of Reunion Islands, and in general, the Reunion Islands also provided a kind of a tilt of the land from west to east. So that slope of the land was developed around the region of Reunion Islands. Aravali's are a fold mountain. Aravali's are the oldest fold mountains that you find in India presently. It is amongst the oldest fold mountains of the world. And it is said that when you had the Bundelkhand Craton, that Bundelkhand Craton would have collided with the ancient oceanic oceanic area at that point of time, and it would have been an oceanic continental convergence. that would have led to the formation of the Aravallis and the fold mountains of Aravallis. That is why in the region around Pataudi that you go, you would have heard about Pataudi, right? The place near Delhi. I'm sure we would have heard about that particular region. Why is Pataudi famous? Many famous celebrities come from there. So, in fact, if you are a follower of cricket, if you are a follower of Bollywood movies, you would have heard about the name Pataudi. So, basically, Pataudi is from where you had Mansoor Ali Khan Pataudi, one of the youngest captains of Indian cricket team. That he was the Nawab of Pataudi. He was referred to as the Nawab of Pataudi. So that is where in Pataudi you have the evidence of old calderas as well, which indicates that there was volcanic eruption also in some portions. And that can happen only when you have a oceanic continental convergence. And presently, Mansoor Ali Khan Pataudi, his son is the Nawab of Pataudi, and that is Saif Ali Khan. So that is where I said if you are a follower of cricket or Bollywood, you would have heard about the name Pataudi. So that is the evidence of the Aravali and its formation. Okay? Any other doubts that we have? Okay, good. Prashant, generally, okay, was it a question by Prashant? No, it was a question by Utkarsh. Utkarsh, generally, the questions that you find from this area will be largely constricted to the portion of locational aspect. That, for example, in the optional or in the case of the prelims, that Bundelkhand is located in which of these states? Uttar Pradesh, Madhya Pradesh, Gujarat, Chhattisgarh. So which of these are correct? So 1 and 2 are correct, right? Baghelkhand is situated in which of these states? So that locational aspect of question is derived from in general studies. But what it also helps you understand is that once you have understood this entire formation process, now let me tell you, you will never get any kind of problem when you have to designate the soil types of country. It will be very, very easy. Whenever you have to think about the mineral distribution of the country, the oldest land masses will always be the richest in minerals because the top portion has been eroded. So the oldest land masses, Aravalis, Bundelkhand, Chota Nagpur, Bastar, Karnataka Plateau, very, very rich in minerals, right? Northern plains, poor in minerals because you have the sedimentary deposits happening there, right? So it helps you in those areas significantly. Okay. Now we come to the portion of the eastern and the western Ghats. Now, just by the image of it, we will be able to make certain conclusions. Now, these Ghats basically are the boundaries of the plateau region, and the boundaries of the plateau region before the region meets with the sea. That is basically the eastern and the western Ghat area. So here, when we talk about the region of the western Ghats, here observe, they are very, very continuous. Western Ghats are also referred to as Sahyadris in the region of Maharashtra, by the way. So here, this is how they are continuous. Right, almost. But look at the Eastern Ghats. They are significantly discontinuous. They are anything but continuous. They are not at all continuous. They are broken. So here you have very ancient rivers. The rivers of peninsular India, they are much, much older than the rivers of Himalayan region because peninsular India has been in existence millions of years before the existence or the creation of the Himalayan area. So that is why here you have very ancient rivers, very old rivers. And these rivers, they cut through this region. Through the region of Eastern Ghats, they have eroded this area quite significantly. And that is why you will find the presence of gaps in the region of Eastern Ghats, but you won't find the presence of gaps in the region of Western Ghats. Okay? Western Ghats are going to be much more steeper as compared to the region of the Eastern Ghats. Why? Because Western Ghats are an escarpment, creation of a fault line. Some portion has sunk down, leaving behind a vertical wall-like portion. Okay? So if you take a brief look at it, so The Western Ghats demarcate the westernmost extent of the Peninsular Plateau. It forms an escarpment on the western slopes, thereby being able to influence rainfall. Escarpment means almost a vertical wall-like feature which is left behind. So that is where the winds, they are forced to rise up, form orographic clouds and cause copious amount of rainfall in the process. Now here, it was formed due to submergence of a part of the land into the sea, the portion which developed a crack and simply sank down. And they are locally known by different names in different regions. So Sahyadri in Maharashtra, Nilgiris in Karnataka and Tamil Nadu, Anamalai and Cardamom in the region of Kerala. That is why, and that is how you have different names. Now, when we talk about the entire process of formation, here, let us understand that. We have talked about it in significant proportion, but still. First of all, after coming to the north of Reunion Islands, already that uplift had been provided. That means the slope of the land was already from west to east. So the land was very much like this, from west to east. Okay. And you had the presence of water in the surrounding areas. You had the presence and the development of water in the surrounding areas. Now, here, there have been multiple changes which have happened since that point of time when India moved to the north of Reunion Islands. The first change which was observed, which was felt, was basically due to the impact of the collision. You had a large crack which had developed. A large crack had developed. And listen to this portion very carefully because it will help you understand the portion of the coastal plains as well. Now, this large crack developed, right? And this portion sank down. Meanwhile, due to the geomorphic processes, you had a rise up, slight elevation. One portion was sinking down, right? In the optional portion of geography, there is a portion of isostasy. Sadly, you don't have to study it for general studies. It talks about, in very brief manner, maintenance of a balance. So if in any area a land sinks down, in order to maintain a large balance or equilibrium, there will be an uprising in other areas somewhat. Just like in the case of Himalayas, we saw that because there was an upfolding, there was a development of a four deep in front of it to maintain a kind of a balance, an equilibrium. Similarly, here also, you had a portion which sank down. And what that led to was development of a steep wall-like feature, an escarpment of sorts, as if the portion had been sliced off. And this portion went under water. This went under water. Even today, it lies underwater. Right? Now, the portion which went underwater, that was like this. It is because of that portion which is underwater. That is why we experience a very wide continental shelf across the western coastline. Whereas in the eastern coastline, especially after the last ice age, there was a kind of an uplift which happened. Slight portions which were earlier underwater, they came up ever so slightly. They came up immersed above water. This kind of minor adjustment keeps on happening in the history of the planet. For example, the region of Rann of Kutch to the south of Gujarat. There also, for example, in 1819, you had a massive earthquake due to which significant portion of land simply got uplifted due to the adjustment of the rocks underneath. it got uplifted, and you had a creation of a sudden new land mass. It was uplifted. And simultaneously, you had another portion of land which went underwater. So simultaneously, these processes, they keep on happening. The Chota Nagpur plateau over a period of time has undergone multiple phases of upliftment and subsidence as well. So these processes initiated by the internal endogenic forces. So some portion on the eastern path that rose up. That meant the continental shelf here, that is much shorter, much narrower. That is why, despite the gentle slope on the eastern coastline has got very smaller continental shelf as compared to western coastline. This is how the formation happened. But this gives us certain clues about the phenomena of the coastline also. What phenomena? Now, when we talk about the western coast, let's say we talk about west coast, and then we talk about the east coast. So in the region of west coast, what do you observe? There's a continental shelf. But if this is the coastline, if this is the Ghats, let's suppose, then small deposits in many areas, very narrow, that if you are moving through the Western Ghats, you'll be able to look at the sea directly, Arabian Sea directly. Then you have the depth and you have the extended portion of the landmass which had underwent subsidence. So here, the water is somewhat like this. Up till this region is where you have the availability or the presence of water. Okay. Now, what does that mean? That immediately next to the coastline, we have presence of deep waters. Ever if you travel to the region of western coastline, you will observe that closer, immediately very close to the coastlines, particularly, let's say if you are moving across the region of to the south of Ratnagiri in Maharashtra, to the region of Goa around Panvel and so on, and to the north portion, Uttar Kannada region. In that area, you will observe that it gets very deep, very close to the coastline. There is a continental shelf underneath, but very close to the coastline, you have deeper waters. Now, presence of deeper waters near the coastline means what? It allows for the larger ships to come closer to the coastline. Because when we talk about very large ships, they require deep waters, right? From our childhood days, we have made paper boats which would float on water, and that has simply murkied our perception about how the ships travel. When the ships end up moving, a significant proportion of their size and weight is underwater. That is why, where you have shallower coastline, ships do not come through. They are very far away from the coastline. They are berthed far away from the coastline. Here, in the western coast, you have that deeper waters. That is why in current affairs, you would have heard about the entire controversy about the Virinium port in the region of Kerala, right? Where India is developing a very deep water port in the southern portion of Kerala, where the water is around 20 to 22 meters deep. That will allow the Panamax class, the largest class of ships, to come to India. Right now, India doesn't have any port where the largest of the ships can come. And that influences our economic capacity in terms of trading nation as well. So this allows for the ships. So deeper waters near the coastline, deeper waters near the coastline allows the ships to come right up to the coast. Right up to the region of the coast itself. This is what makes the western coast ideal for natural development of ports and harbors. Hence, western coast is naturally suited for ports and harbors. Okay? Whereas across eastern coastline, what happened? A portion of the landmass came above water, shortening the continental shelf, but also the slope of the land. Let's suppose this is the region of the Eastern Ghat, small hills of the Eastern Ghat. Slope of the land was very, very gentle. So here, let's suppose this is the slope of the land. So let's suppose the water is up till here. This is the coastline. So the depth of water near the coastline, that is going to be very shallow, very, very shallow in nature. So that means larger ships can never come there. This is why eastern coast is not suitable for berthing of larger ships. And that is why the only exception is Vishakhapatnam port. Vishakhapatnam port is a natural deep water port, but not as deep as many of the ports in the western coast. But Vishakhapatnam amongst the eastern coastline is deep enough. Tuticorin is another deep water, but you don't have enough deep water ports. So that is why western coastline is naturally more suitable for formation of ports and harbors. Now this portion has emerged above water. Some portions, significant portions, were underwater. Now a portion which lies underwater and now is above water, what kind of natural resource do you think will be found in that portion? Let me know. A portion which has remained underwater but has emerged above it, what kind of natural resource will be found in that region? Any of us? When it has emerged above water, why will you find corals there? You will find remnants of corals. Good. Anand, Binita, Aarti, Shubhajit, very correct. You'll find fossil fuels, crude oil, petroleum, natural gas. That is why here you will find in this portion what is the Krishna Godavari basin, particularly rich in crude oil deposits. Whereas across the western coastline, the portion which has sunk underwater, you'll find the presence of crude oil across the coastline in the region. If I take you to the map, is here that you will find crude oil. That is where you have the Bombay High, which is situated there. So like that, if you know the formation, automatically the mineral distribution and the mineral resources will flow naturally to you. So here we have understood the formation of these ghats. We have understood the basis of the coastal plains also. We'll talk more about it when we come after the lunch break. So we'll take a lunch break and we'll be back by 2:05. Okay? Is that portion understood? All the portions till now, is it understood or is it simply moving above? Okay, Binita, please explain again why Eastern Coast Continental Shelf. See, Western Coast Continental Shelf will be much wider. Why? Because the land has subsided and sunk down, and that is forming the continental shelf. So always the western coast continental shelf will be much, much wider. Whereas when we talk about the eastern coast, the portion has emerged above water in the recent history due to endogenic forces. Now, when it has emerged above water, what does that mean? That now the earlier present continental shelf that has become narrower. Is that understood or not? Again, I will repeat. Listen to this very carefully. western coastline is wide. A western portion or the continental shelf in the western coastline is much more wider. Why? Because a portion of land has sunk down, a portion of land has subsided, right? And that has formed the continental shelf. This will be much wider. Whereas across the eastern coastline, a significant proportion of land which was underwater has now emerged above water. So the shelf area has shortened. Okay, perfect. So, okay, we take a break and we are going to be back by 2:05. Aarti, yes, I would advise you guys to revise it as soon as possible because generally all this compilation of information not to be found in the book. So if you are reliant on a particular book, there are chances you will be disappointed in that. So kindly revise the portion of the PPTs and the annotations. You'll be in a much good place. Okay, so we meet again after break, and then we will continue with the portion of the Eastern Ghats, the coastal plains, the island formations, and also the river systems of the country. Okay.